Okay, now you can notice that in our equation we have y equals ax squared plus c. We're adding a c value to it. If you read at the top of your page there, it says the y-axis is the axis of symmetry for the graphs of y equals ax squared plus c. That c value is going to translate your graph up or down. So it's going to move the parent function either up or down on your graph. But we're going to graph our parent function so you can see this happening. So the first one we have y equals 2x squared. And again, we can use our -2, -1, 0, 1, and 2. Since we know that it is symmetrical, we don't have to plug in our -2, -1 values. We're just going to plug in the 0, 1, and 2. So we're going to plug in the 0 for our x. So 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. And then 2 squared is 4 times 2 is 8. And since we know that it's symmetrical, we can go back up to -1 and say -1 is 8. I'm sorry, -1 is 2, and -2 is 8. So our points, as you can see, writing there on the left side. So we'll go ahead and go graph that one first. We'll start counting by ones on all of these for our x and our y value. So we're going to go to 0, 2 to start our first graph. I'm sorry, 0, 0 for our vertex. Then we're going to go to 1, 2, and then 1, 8. 2, 8. And then, like we said, we know it is symmetrical, so we can mirror it across that y-axis. So we have our first parabola that we can draw in there with our U-shaped graph. Obviously, hopefully yours is going through the vertex. There we go. So we're going to plug in the same values for the other function of 2x squared plus 3. And again, it's still symmetrical, so we can just use the 0, 1, and 2. So 0 squared is 0 times 2 is 0 plus 3 will give us 3. 1 squared is 1 times 2 is 2 plus 3 is 5. And then 2 squared is 4 times 2 is 8. Plus 3 gives us 11. So we have the points of 0, 3, 1, 5, and 2, 11. Again, it is symmetrical, so we can make -1, -5, and the 5 stays positive, so -1, 5, and then we can do -2, positive 11. So now we're going to go in and graph these. We have 0, 3 now as our vertex. We have -1, 5, and then we have -1, 5, and then we have 2, 11, which just off of our graph a little bit there, and then -2, 11. We'll graph this parabola. And we'll notice that you can see they are the same parabolas graphed. The only difference is that you are translating that up 3 units. So if you look at your equation, you can see whatever your c value is, that is going to tell you where you're moving your graph. So if it's plus 3, you're moving it up. As I'm sure a lot of you are already figuring out, if it's a -3, you can figure out what it's going to do to your graph. Go ahead and pause the video, do your got it now, and then come back and check to make sure that you are correct. Make sure that you plug in both the parent function values as well as the x squared minus 3 values. Okay, as you can see with our graph here, we have the parent function in black. We have the points of 0, 0, 1, 1, and 2, 4 with it mirrored across the y-axis. And then since we had a -3 or -3 for our c, that shifted our graph down 3 units. So again, when you plug in your values, or if you have a graphing calculator and you're using your y equals function and then hitting second table, you can go figure out your values of the table rather than doing the algebra for it.
All right, our last example today involves a real-world example where an acorn is dropping from a tree branch. It's starting 20 feet above the ground. So it's giving you this function right here to model that, where h is the height of the acorn. So the plus 20 at the end shows you that it did start 20 feet above the ground. It is going to fall to the ground, and so it wants us to graph this function and then determine at what time did that acorn hit the ground. So if you do have your graphing calculator, you could just type this function into your y equals and go to the table, or you can plug in each of these values. We have picked smaller values as the acorn will hit the ground fairly quickly. So you can plug in each of your values. So I'm plugging in 0 for t. 0 squared is 0 times negative 16 is 0 plus 20 is 20. So that point is 0, 20. So I'm going to count by 5s here. So 5, 10, 15, 20. So my graph will be starting right here at 0, 20. Notice that we only have the first quadrant here, as we're not talking, we are talking real world. So the acorn, when it falls from the tree, is not going to go below the ground. So this y-axis is representing the height of our acorn, and the x-axis is representing the time. So we are not going to have negative time. Okay, so I can continue plugging in my values here. That will come out to equal 16. You can use your calculator if you need to do that. So that point is 0.5, 16. Okay, continuing on, plugging in each of your values. That will come out to equal 4. Okay, so that is 1, 4. And then plugging in the 1.5 will come out to equal negative 16.
Again, notice how she's using very small increments of time because it is not going to take an acorn very long to fall. So we don't want to do 1, 2, 3, 4 seconds because it's probably not going to take it that long. Also notice on your graph is not going to look like how the acorn is going to fall. Obviously the acorn is going to fall straight down. We are graphing the amount of time elapsed for it to hit the ground.
So I am going to count by 0.5 what I was going for here for my t. So this is 0.5, this is 1, and this is 2. So I'm plotting my points, okay, at about 16 seconds, which would be right here, or 16 feet at 0.5 second. At 1 second, it's at 4. And then by the time we're at 2 seconds, or 1.5 seconds, it's all the way down at negative 16, which we know it's not going to fall that way. So it's asking you, at about what time is your acorn going to hit the ground if you connect your dots like this? So it does look like the acorn is going to hit the ground about after 1 minute. 1 second. Okay, it'll hit the ground about after 1 second. So about what time? It's by 1 second, and we got that by graphing it and seeing where the height was 0 at the time. So go ahead and pause and do your got it problem now using this new function. Use small increment values. Maybe you want to use the same ones and see about at what time will the acorn hit the ground.
So as you plugged in your points, you will realize that it will land at the ground just over 2 seconds. At 2, you add 6 feet off the ground, so it's going to be just a little bit over that. Your summary now is questions over the lesson. Now is when you would write any questions that you may have had over this lesson and then bring those to class, and we will answer those tomorrow.